Hello. I was trying to make another charger, but this time I did not want it to make a toroid, and I needed something stronger than fixed inductors, and I've asked myself, is there a way to use a Super Joule Ringer type of circuit and make a better charger? And well, here is the result. I am driving the circuit with a 12-volt battery, charging a 4-volt battery, also a AA battery at the same time. Here I'm making some tests, and this is what happened. Here from the collector I'm charging the AA batteries. The battery was with 1.2 volts. Now it's pulsing or pumping between 1.26 to 1.3. Soon it will get down to 126 and go to 1.3, then go back to 127, then go to 1.3, go to 128 and go to 1.3. I'm still testing, but here is what I've tested so far. Here I'm coming on this LED, I'm coming from the collector, and this is what I found. If I place from the collector just an LED and a battery, it will charge faster. If I place a diode here, a diode and an LED, it will take longer to charge. So I have these two options. I'm calling it a slow charge, and B, a faster charge. I'm trying to do this to charge my AA batteries from my camera. Here is the same of the chargers I always use, and I'm using a common transformer, right? This is transformers that you find inside those wallet power supplies. This one, or like this other one. These are transformers you find in all the wallet power supplies. Have these transformers, I mean from 9 volts on, so it's easier to find. You can find this on the trash. People throw these things away all the time. You don't need to make yourself a toroid or something, and it's like the Super Joule Ringer. On the low voltage side, I'm connecting the positive, and on the other side the collector. And here on the high side I'm connecting the base, and here I've placed a protecting diode. It's not on, it's off. It turns on here's this LED in here. It turns on when I disconnect the charging from the high voltage in here. And why I placed a neon in here after the diode, the first diode, is because if I'll try to show here on this LED wire here, I'm coming after the LED in the circuit here. After the LED, I'm coming to the positive of the charging battery. When I disconnect this wire, watch the neon here. I'm going to disconnect the wire from the positive. No, this time the neon did not turn it on. Normally it would turn on. Why this time it did not turn on? Oh, because the collector is here charging the AA battery. Now the battery is charging to 128, 127, and then gets back to 130, 130. Oh, here. Now turn it on, the neon. I've just lowered down the potentiometer here, and you see the protecting LED diode turn it on, and the voltage on the battery got up to 138. So I can adjust in here the maximum output. Now the battery, the AA battery, got up to 14 volts, and I'm going to connect again the positive of the charging battery. The neon will turn off, and oops, the neon turned off. The protecting diodes, it's very weak, and the charging battery here came back to normal. And I think I'll try to box this thing. And here is another LED. I placed an LED after the potentiometer because I'm using 2N2222. So I needed a cheaper transistor, simple transformer that I can find easier, and a very well, I'm still trying to test the chargings, but another way to charge my batteries with cheaper components is a 10K potentiometer, a 2N2222, and a normal transformer that you can find on any power wallet supply. And this is it. The AFIC Super Joule Ringer MultiCharger. Here's the circuit again. I think you can understand. Here are the places of the batteries: the fast charge, the slow charge, the charging mode. The protecting of the charging mode is this neon. When you disconnect the battery from charging, the power will go through the neon to the positive. Here is to prevent sometimes when I disconnect this from here, if I don't have this thing, the battery increases the discharge. It's very funny, this circuit. But I just placed the diode in here for the pulses not to reach the battery and go straight to the charging battery. I think this is it basically, and thank you for watching. This needs more tests. Okay, these are the first tests on the circuit. I still need to watch for the results, but the battery is with 4.16. It was with 3.8 volts. The charging battery is 128. Let me disconnect this from the charge. I'll first disconnect the positive from the positive rail, and now I'll disconnect the negative rail. The battery is crazy. Why it is crazy? Oh, here. Yeah, it's 126. It was with one. I don't remember, but it was not with 126. I'll connect again. First connecting here, and after connecting the positive. Okay. Everything back to normal. So this is it. Another cheap way, maybe another cheap way to charge your batteries. Charge more batteries at a single time. But this needs more testing. Okay, if you want to box it and use it, build one and test it. Thank you for watching. I've changed the 1.2 volt battery for an old battery from my electric tool. Is two batteries of 1.2 volts, and they are in series connected here. I think they are 1.2 volts, right? Yeah, 1.2 volts each. 1.2 volts each. They were with 0.7 volts. 142. And I'll try to see what will happen with them too. The other battery that was disconnected is with 126. I'll try to see how long a Joule TIF will run this battery. The lead crystal battery is now with 116. $416 going to $417. I just decreased the resistance on the potentiometer. All the LEDs are very, very bright. Okay, thank you for watching.